Physics students, good afternoon. Mr. Fugit here. In our video today, we're going to be looking at a few problems from our review on test number 5. Specifically here, we're going to be looking at questions 7 and 8, the final two questions on test 5 review. These questions specifically will help us look at the ideas of power as they relate to work and energy. We'll go ahead and get started with problem number 7. As always, the problems that we will be working through are available on Canvas, and there are keys there as well for you. So, question 7 says this. A jet engine supplies a thrust force of 510,000 newtons and flies at a speed of 240 meters per second. How much power does the engine output? So here, in question number 7, we are given a force as well as a speed, and we can actually use those in one equation to find the power output of an engine. Power is equivalent to the thrust force of an engine multiplied by the velocity of the object that is moving as a result of that force. So, the thrust force involved here was 510,000 newtons, I believe, yes. Multiplied by the velocity, which was 240 meters per second. So if I multiply these values together, we get approximately 510,000, 240. Very large number. I'm going to write the whole number out. This would be looks like about 122 million watts. Now, typically when values are that large for power, they're oftentimes converted into other units. Different prefixes that we can attach to kind of scale our numbers down a little bit. If we converted this to kilowatts, it would be about 122,400. We could also convert this to megawatts, dividing our value by 10 to the 6th, and we would get about 122.4 MW, megawatts. Excuse me. So here we're using our straightforward equation for power. This is typically used for things like jet engines, when we know the thrust force that we are supplying from the engine, as well as the velocity of the object. So here we can use this approach to find the power output of this engine. So we'll come to a new page, we'll look at problem number 8. Problem number 8 says this. I push a 30 kilogram crate along a rough level surface with a coefficient of friction of mu equals 0.35. If I push at a constant velocity of 2 meters per second, how much power am I producing? So in question number 8, we have a velocity and maybe some information about forces. So we might be able to use our power equation again. Force multiplied by velocity. We already know our velocity is 2 meters per second. So here we're told we are pushing a crate forward, I believe. Yes. And we're told we're pushing at a constant velocity. There's a force of friction working against us because we are given a coefficient of friction here. We've also got likely a force of gravity. We can assume we're on Earth. And a contact force between the ground and the crate. Now we want to find the strength of our push force. So we're probably going to need to look at the x direction here. So bringing in some of our ideas from previous units on Newton's laws and forces. The sum of forces on an object is equal to the mass of that object multiplied by its acceleration. Now we're told we have a constant velocity, so our acceleration would be 0, and mass multiplied by 0 would be 0. So now I've got my sum of forces, my push force, minus my force of friction. I'm going to say that my force of friction is negative, it's to the left, and our push force is positive, it's to the right. Those must equal 0, which means if I move my value for the friction force over, then my push force would equal my force of a kinetic friction. So I know that my push force must equal my force of kinetic friction, based on what we know with Newton's second law. Now from here, our force of kinetic friction is equal to our coefficient multiplied by the normal force. So I know the coefficient, I'm told it's 0.35. I just now need to find the normal force. Now since that's in the y direction, I would maybe need to look at Newton's second law again, but now with respect to the y direction. Let's do that real quick. the sum of forces on our object in the y direction is equal to the mass of our object multiplied by its acceleration in the y direction. In the y direction, I have two forces. My normal force, I'll say that's positive because it's directed up. My force of gravity would be negative because it's directed downward. And acceleration in the y direction. Well, we're told we're pushing the crate across a level surface, which means it's not accelerating up or down. So our acceleration in the y direction would be 0. And any value multiplied by 0 is also 0. So our normal force, we can then assume is equal to our force of gravity. And we actually have an equation for that force of gravity. The mass of our object, m, multiplied by g, gravitational acceleration. So our mass here, we're told, is 30 kilograms multiplied by 9.81, and we get approximately 294.3 newtons. Now, this is not the force that we need. This is our normal force. We're going to bring that up and use it here in our equation for force of friction. Our force of friction is our coefficient, 0.35, multiplied by our normal force, 294.3 newtons. So I'll multiply 294.3 by 0.35. That gives me 103.01 newtons. So now we have our force of friction, and we already showed a moment ago that our force of friction must equal our push force because our object's moving at a constant velocity, therefore it has no acceleration. So now that I know my force, 103.01, and I know my velocity, I can actually find the power that I am supplying to the object. And the power I'm producing, as the problem says. So power is equal to the value for force multiplied by velocity. Our power here is 103.01 newtons. That's our force that we applied, multiplied by our velocity, 2 meters per second. So I'll multiply these values together, and I get right about 206 watts. So the power I am producing would be equivalent to 206 watts. And if we check our results, looks right on track. So, really, the equation that we use for power here is pretty straightforward and standard. The challenge here is going through the application of Newton's second law in order to find the forces that we need. But hopefully this gives us some good direction on where to go with questions 7 and 8 using an equation for power, along with some of our previous ideas of forces. And as always, if you have questions, then you're welcome to ask and direct those my way. You can also access Canvas for other resources. Good luck.